Chapter 5 is all about polynomials and functions. So we've already done a few polynomials so far this year. You just didn't know they were polynomials? But polynomials is a huge topic in algebra. You'll see it in pre-calc. You'll see it in calculus. Polynomials are a really important topic. Okay, so now we have to first go through some definitions and some examples because I'm going to use some terms like polynomial, and you need to know what that means, right? So we're going to do some definitions, and you're going to learn these. All right, so first of all, we're going to start with a monomial. Do you know what mono means? One. Mm-hmm. Mono, it is. It's the kissing disease, yeah. Is it from kissing one person? I don't know. All right, monomial is, it means one. So for a monomial in math language, it's when you have a single term. Single term, okay? Shoot. Okay. Now this single term is, what am I doing today? There we go. This single term can be one of three things. It can either be a number, okay? Or a monomial can be a variable, or it can also be the product of a variable and a number. So a monomial looks like this. I'm going to run out of room on this thing. It looks like this. Ax to the n power. And n is going to be a counting number. Do you remember what counting numbers are? Counting numbers, we learned what types of numbers there are in the first day of school, so that was a long time ago. Counting numbers are like if you were going to start counting off people, you would start with 1, 2, 3, 4. So n is going to be 1, 2, 3, 4, not negatives, not fractions, not decimals. They're nice numbers, exactly. Okay, now we're going to talk about the degree of monomials, and the degree of the monomial is going to be the exponent of the monomial, but it's not just the exponent. It's the exponent of the variable of a monomial. So if a monomial doesn't have a variable, then its degree is 0. Because it doesn't have a variable, it doesn't have an exponent on that variable, it's 0. So let me give you some examples of some monomials. Here we go. 7. 7 is a monomial. 3x is a monomial. Negative 10x to the 6th power. 1/3 x squared. And 5 to the 4th. Those are all monomials. Okay? They're all separate terms. There's no pluses or anything in between. There's like almost like a group of things put together, and they're each different monomials. Now let's talk about the degree of each of these different monomials here. So the degree of 7, you have to look at the exponent of the variable. 7 doesn't have a variable, so its degree is what? 0. Perfect. 0. What's the degree of 3x? What's the exponent on that variable? There is none. There is, though. 1. We just don't write it because it's just automatically known. So the degree of that monomial, the degree of 3x is 1. What's the degree of negative 10x to the 6th? 6. Perfect. The degree of 1/3 x squared? 2. The degree of 5 to the 4th? 0. Ah, I tried to trick you there. You were going to say 4. Yeah, there's no variable. That's a constant. 5 to the 4th is actually, what is that? 625. Yeah. So what's the degree of 625? 0. Now, things that are not monomials, I'm going to write these in red because they're bad. Not monomials would be things that we're not going to study in this chapter. They would look like this. 5 over x squared. That's not a monomial. Okay, you can't have variables in the denominator of fractions. Something else that's not a monomial would be x to the negative 6th. Okay, see that negative 6? It's a negative. We are doing just the nice numbers, 1, 2, 3, 4, 5. Yeah. Something else that's not a monomial would be the square root of 3x. So no square roots of variables, okay? All right, and then finally the last thing for this part is the monomial standard form. I already wrote it down, but the standard form of monomial just looks like this. A times x to the n. That's it. Okay. Now, so monomials, one term. So what's a polynomial? Do you know what poly means? Many, yes. Like when I worked at Polly's Pies, many pies. No, that's not true. It was the name of the old lady that made the restaurant up. But poly means many. So polynomial is when we're going to take these monomials and we're going to put them together. So a polynomial is a monomial, or it's the sum or difference of monomials. Monomials. So a monomial is a polynomial. It just has one term. But when you take some monomials and you add them together or subtract them from each other, then you get a polynomial because you get many monomials together. All right, so the degree of a polynomial is going to be very important to what we do today. The degree of a polynomial is the largest exponent of any of the monomials. The largest exponent on the variable, okay, it's the same thing. It's like you look at all the different monomials and you decide which one's the biggest, and that's going to be the winner, and that's the degree of the polynomials, the largest exponent of a variable. All right, so let me give you some examples again of some polynomials, okay? We've studied polynomials before. We studied this polynomial, 2x plus 3. 2x plus 3. We did that in chapter 2. We graphed those. Y equals 2x plus 3. Those were polynomials. You just didn't know. Something like 9x to the 5th minus 3x plus 1. That's a polynomial too. And then let's do one more polynomial, this one. X cubed minus 10 plus 8x squared plus 5x minus 7x to the 4th. Yes. I could keep going forever, but that's a polynomial. It has all these monomials, those all are monomials, and I just put them all together with pluses or minuses, and that makes a polynomial. So let's talk about the degree of each of these. So what's the degree of the polynomial 2x plus 3? 1. Yep, it's the largest exponent. So this one has two terms. There's a 2x and there's a 3. And then the 2x kind of wins. It overpowers everything. So which one wins here? 5. The degree of that polynomial is 5. Okay? And the degree of the last polynomial here? 4. Yes, 4 is the biggest exponent that I see. I see a 3, a 0, a 2, a 1, and a 4. And so the degree of that polynomial is 4.
Whoa.
I know.
Wow.
Okay, now standard form of a polynomial, and you've done standard form before. Remember on the test when you did ax squared plus bx plus c is standard form for quadratics? Well, that's standard form for polynomials too, on a much bigger scale. So the standard form for polynomials is when you write them in descending. Do you know what descending means? Starting from the highest and going down. Descending exponents. You want to write the largest exponent first, monomial with the largest exponent, and then go down from there, okay? And the leading coefficient, once you get that polynomial in standard form, it's going to be that leading number out front, okay? It's the number in front, just the number, not the variables. It's the number in front in standard form. I always abbreviate standard form as SF. I know that's San Francisco, some of you, but standard form. All right, so let's look up above here. And we're going to put the third polynomial in standard form. So the third polynomial is this long one that I did right here. We're going to take this polynomial, and we're going to rewrite it so that it's in standard form. That's going to be what we wanted to have it in standard form, because then we can answer the questions better. So what's going to go first? Good. Negative 7x to the 4th. Descending order of exponents. The next one would be positive x cubed. And then 8x squared. Good. 8x squared. After that is 5x minus 10. Okay, it even feels better, doesn't it? Like when I wrote it up here, it's so jumbled, and when are you going to stop? And, you know, if you write it in its descending order, it feels orderly. It feels good. Maybe not to you. Math does not feel good, but it feels good. Okay, so what is the leading coefficient? Yes, the leading coefficient is that number that you see that's leading the pack, right? It's leading that whole polynomial out. And so it would be -7 is the leading coefficient. So far, so good, right?
So far,
okay.
So great.
Right? All right, now we're going to classify a polynomial. We're going to classify it 2 ways, and you're going to be required to know these terms that are coming up. So we're going to classify a polynomial by its degree, and then we're going to classify it by the number of terms that it has. Okay? So let's start by classifying it by its degree. So if a polynomial, the lowest degree that a polynomial can have is 0. And if a polynomial is degree 0, then we call it a constant. And the reason why we call it a constant is because if it has degree 0, it's going to be just a number. Like, for example, the number 10. Does 10 change? No, 10's 10. 10 is always 10. X can change. X is a variable. You know what variable means? It varies. X can be 3 today, tomorrow it's -7, right? 10 cannot change. 10's always constant. Okay, then the next degree would be a degree of 1. And we studied these in chapter 2. And this would be linear. And they're called linear, why? Because they are lines. So we would have something like 2x minus 5. That's a polynomial with degree 1. It's linear. When you graph it, it's a line. Now, we just spent an entire chapter, chapter 4, on polynomials of degree 2. Quadratic, yes. And isn't that strange? Don't you feel like quad means 4? Quadratic. Quadratic, yeah. And quadratics look something like, I don't know, -3x squared plus 1. That's an example of a quadratic. It's a polynomial of degree 2. We solved those. We did all kinds of stuff with them, right? All right, then you have a third degree polynomial. Now let me tell you before you shout it out. If you take a number and you raise it to the third power, what do you do to it? You cube it. So these are called cubic functions. They're cubic polynomials. Degree 3 has a third degree polynomial. It's a cubic. So something like this. 5x cubed plus 2x squared plus x minus 3. That is a cubic because it has degree 3. And that's what we call it. All right. And you're probably wondering how many more are we going to do?
Wait,
2 more.
You gotta leave those right there. Stop.
Leave them? Oh, yeah. Okay. If it has degree 4, do you know how many things are in a gallon? There's 4 things in a gallon. You know what they're called? Quarts. Yeah. These are, it's called quartic. 4 quarts in a gallon. Quartic. Quartic could look something like this. 7x to the 4th plus 3x. There's a quartic polynomial. It's missing terms in the middle and it doesn't have to have all of them. It just has to be x to the 4th. What doesn't make sense? This?
What?
Are you doing something else? Wow, Fraley, calm down, dude. Just relax, okay? You're scaring me now. All right, number 5. And the last one, and you know what? I'm going to let you guys pronounce this because it's actually pronounced 2 different ways. Kind of. Yeah, the Quintic or Quintic. Some people say Quintic. It's Quintic. Quintic, okay. A Quintic is degree 5. So something like -10x to the 5th plus 3x squared minus x, okay? That's Quintic. It's funny, when I was a kid, there was this toy that came out, and I really wanted it, and it's kind of creepy when you think about it. But it was like this doll, and it was a mom, and she had 5 babies.
That's really creepy.
It was. It was called the Quints. Yeah, and it came with a stroller with 5 babies, like, could go in the stroller. It was cool. It's like so Octomom, right?
But how do you, like, I don't understand, like, what's so fun, like,
why would you want 5 babies?
Yeah, that's
right? I don't know.
5 times going through.
No. Yes. Okay. Now, oh, by the way, after that, There are 6th degree, 7th degree polynomials. We do not go that high. We usually stop around 5. So those are the ones you're going to be responsible to know. Now, we also classify a polynomial by the number of monomials that it has. Something can have one term, it's a monomial. Something can have 2 or 3 or 4 or 5 or huge things, okay? So if it has one term, we already know it's called a monomial. For example, 5x to the third. That's a monomial. It has one term. It doesn't have anything to do with what degree it is. All we do by classifying these is how many terms does it have, how many numbers of them. If something has 2 terms, we call it a binomial. Like bicycle has 2 wheels, right? Okay, so a binomial could be something like 7x to the 5th plus 3. That's a binomial. 2 terms. If it has 3 terms, what do you think it's called? Yes, trinomial, like tricycle, triangle. Ooh, I learned yesterday Triceratops has 3 horns. That's kind of cool. Trinomial. So trinomial, we did a lot of trinomials. We did x squared minus x minus 6. And don't you just want to factor that? Yeah, you do. Okay, you don't. All right. Maybe it's just me. All right. And then after that, 4 or more, we call it just a polynomial. Kind of boring. Yeah, we don't want to learn too many words, right? Okay? So if it has 4 or more, these are all polynomials, by the way. It's just they have specific names. 1 term is monomial, 2 is binomial, 3 is trinomial. 4 or more is a polynomial. Okay, so now we're going to go ahead and we're going to have a chart on the back. The next quiz you have, which is next Tuesday, you will have a chart just like this that you're going to have to fill out. Knowing all of those things now, let's put them to work. Here we go. We're given these things over here. Now, these are all polynomials, but they might not be necessarily written in standard form. Standard form is not going to include any parentheses, and everything has to be in descending order, okay? You have to add your like terms. You have to simplify the polynomial completely. All right, so here we go. First thing we're going to do is standard form. This one, I gave you an easy one to start off with to ease you into it. It's already in standard form. There's nothing else you can do. So 17x is its standard form. What is the leading coefficient? That's what LC means. Leading coefficient is 17. It's the number that's leading the polynomial. Okay, what degree does this polynomial have? It has degree 1. And by its degree, we say that if we're going to graph that, it would be linear. By its degree. I know people will switch those up on accident. You have to look at the degree, and a degree is 1. It's linear. And then how many terms does it have? It has 1 term, so it's a monomial. All right, let's look at the next one. The next one is, well, I've got some like terms here, huh? So let's go ahead and add this up. If I have 1x cubed and I take it and add it to 3x cubed, how many x cubes do I have? 4x cubes. So 4x cubed plus 5. So simplify your polynomial first, and now we get to answer the questions. So what's the leading coefficient of this polynomial? 4. It's the number out front. Okay. The degree of it is 3. Degree 3. Based on its degree, what's the name of this polynomial? It's cubic, right? It's being cubed. Okay. I think that'll help you remember cubic. Cubic is being cubed. And then finally, how many terms does it have? It has 2 terms, so it's a binomial. 2 terms. Okay, you try number 3 by yourself. All right? Rearrange it, get it into its right form, answer those questions there. Cool. All right, so there's no like terms. So we have negative 3x to the 5th minus 5x cubed. I'm going to run out of room here. Plus 2. Ooh, I fit it. All right, what'd you get for the leading coefficient? Negative 3. What's the degree of this guy? 5. His name, according to its degree? Quintic. Quintic. And then the name of it, according to how many terms it has, it's a trinomial. Nice. Okay. Now, the next one I'm going to do with you because it's pretty bad, and we're actually going to go to the bottom of your page, and we're going to have to show a bunch of work here. All right, let me go ahead and tell you about this one. This one right here, yes, you're going to have to, here's the game plan on this problem. You have to first FOIL that, and then you have to FOIL that, and then you have to subtract, okay? So here we go. We're going to take x plus 2 and multiply it times itself. That's the first part. Because a lot of people think x plus 2 squared is x squared plus 4, but that's not true. It's a binomial. You get a middle term here. We go x times x is x squared. Outside is 2x. Inside is 2x. And then the last term is 4. And so what I get here is I get x squared plus 4x plus 4. Okay, that's the first part. That's just this part right here. Now I need to take the other two and FOIL them out. So I have x minus 2 times x plus 6. Okay, so let's FOIL again. It's not hard, it just takes a while and you're probably mad and stuff, but whatever. All right, x times x is x squared. Outside gives me 6x. Inside is negative 2x. And my last term is negative 12. So I end up getting from that x squared plus 4x minus 12. Now what I need to do is I need to take my first one and subtract my second one. Okay, we're subtracting here. Subtraction means you have to subtract all of them. Okay? So I'm going to subtract x squared minus x squared. Guess what? They cancel out. Then I'm going to subtract 4x minus 4x. Those cancel out too. And then I get 4 minus negative 12. 4 minus negative 12. What is that? Can you do that in your head? 4 minus negative 12, yes, is 16. After all of that, it's really just 16. I know. Okay, so write it down. It's 16. So what is the degree of this, or leading coefficient? 16. The degree is 0. It's constant. 16 never changes. If you're 16, then you're 16. True. Your age is not constant. 16 is, though. And then, that says constant. Can you read that? And then it is a monomial. There we go. Okay, one more of these, and then we got to go on to the next one. All right, so these we're subtracting. There's no foiling here. It's just subtraction. So if you take a look, we have an x cubed minus an x cubed. And then 2x doesn't subtract with anything. And 4 minus 4 is gone also. So what I'm left with is negative x squared. Do you see that? Yes. The negative has to distribute to the x squared. It's negative x squared plus 2x. All right, so that's kind of the harder part, I think. The rest of it, you guys can just memorize these things, what they are. But the algebra is tough. All right, so the leading coefficient for this one is what? Good, it's negative 1. It's the number out front. There's no number there, it's automatically a 1. And then the degree is 2. We just studied these. They're quadratics. Quadratic. And it has 2 terms, so it's a binomial. There we go. All right, do you need to stretch for a minute before we go on to the next one? Okay.
I want to be like...
All right, 5-2 is all about the factors and zeros of polynomials, okay? Now, you should know what factors are already because we've already done factoring a lot. And then we're going to learn today what zeros are. Okay, it says right here. Ready? If p of x is a polynomial function, the solutions of p of x equals 0 are the zeros of the function. Okay? So when you set a polynomial equal to 0 and you find out what works, those are called the zeros. That's what they're called. So let's do these 3. It says write the polynomial in factored form. We know how to do that already. And then we're going to find its zeros. Okay? So let's first factor this. Now remember, when you're factoring, you always want to look for a GCF first. That's always your first step. greatest common factor. So this one right here, number 1, letter A, perfect. Factor an x out. I heard it.
Yeah.
Who said that?
That's coming from you.
Oh, very good. All right, so there we go. Factor an x out, and then you want to keep factoring. You don't want to leave it like that. We're going to do good old star method. Negative 15 up top, negative 2 on the bottom with a 1 and a 1. Are you guys getting good? You don't even need the star sometimes?
Yeah.
Good.
I'm never that.
So what times what's negative 15 adds up to negative 2, negative 5, and 3. Okay, so the first step in doing these is to write them in completely factored form. So x minus 5, x plus 3. That's half of the answer. See, the problem says write the polynomial in factored form. Okay, did that. And find its zeros. Now the zeros are going to be whatever makes this polynomial 0. Whatever x is that I plug in makes it 0. So we have 3 factors here.
Gotta do this stuff again.
Yep, on a bigger scale. We did it already. I'm so glad you recognized that. We did it with quadratics, right? Now we're doing it with polynomials. So we have 1, 2, 3 different factors. 3 x's, different x's can make this thing 0. So for my first factor right here, what can make that 0? 0. People don't like that one though. That one bothers them. It's actually the easiest one. Like, what do I plug in for x to make it 0? 0. Okay, the next factor, what do I plug into the next factor, this one, to make it 0? 5, perfect. And finally, the last one, negative 3. So you guys are good at this part. You've already done this all before.
So it's not what makes the entire thing 0?
Yes, if I were to plug in 0, guess what? 0 minus 0 minus 0, it makes it 0. If I plug in 5, it would make it 0. And if I plug in negative 3, it makes the polynomial 0.
Oh.
I know, all 3 of those. And guess what? Here's something that I'm going to kind of, like a little spoiler alert. Do you see how this is a 3rd degree polynomial? How many zeros did we get?
Oh!
3.
Oh my god.
It's not a coincidence. Okay,
Got it, BJ?
you try B. You try this one. Okay, you try it. Factor it and find its zeros. It's exactly like letter A.
Exactly.
Yeah, except for the answers are different. The process. Yeah, fairly. Sorry, I assumed. Okay. Factor out an x and you're left with x squared minus x minus 12. Now, maybe you're getting so good at factoring, you don't even need that star. This would be x, minus 4 and plus 3. Star method, okay? Now, that's half of the question. The second half says to tell me the zeros.
0.
0, 4, negative 3. Good, yay. Okay, and if you did pretty good on that last chapter, then this is kind of just an extension of that. All right, let's do the last one together. Factor out an x. I wanted to do this one because a lot of people forget how to factor the difference of 2 squares. But it's actually a really nice special thing, right? Where you just do x plus 3, x minus 3. And so then your zeros of the polynomial would be 0, negative 3, and positive 3. And you can write that as plus and minus 3 if you want to.
Oh.
Okay, let's move on. Now we're going to go backwards. Okay? We're now, well, let's talk about this. It says x minus a is a factor if and only if a is a 0. We'll just do one of these. Okay? It says write a polynomial in standard form given the zeros. Now, if I'm given that these are zeros, then my polynomial will have factors. Okay, we're going backwards. Instead of here are the factors, you tell me the zeros, I say here are the zeros, you tell me the factors. So what factor would go with negative 2? X plus 2. That's right. And what factor would go with 2? X minus 2. And then the factor that goes with 3 is x minus 3. See, it's working backwards from where we normally do. I normally give you these factors, you tell me the zeros. But I told you the zeros, you put them in the factors. And now guess what we get to do? FOIL. We're going to FOIL the first 2. And then we're going to FOIL the last one. Here we go. X times x is x squared. Minus 2x on the outside. plus 2x for the inside, and then minus 4. Now simplify that first, okay? That simplifies to x squared minus 4. Ooh, that's nice. And now we got to FOIL that times x minus 3. So we'll FOIL this out. We get x squared times x is x cubed. Outside gives me negative 3x squared. Inside gives me negative 4x, and my last term is 12. And there it is, my polynomial. It's in standard form, which is nice. I don't have to rearrange it or anything. There's no like terms, and that would be it. Okay? So these aren't that hard. They just, they just take a lot of work, a lot of time. Okay, for this one over here, we're not actually going to do it, but I'll show you how to set this up. If I have a factor or 0 that's 0, the factor that goes with that is just simply x. And I have x minus 4 and x minus 4. Okay? So my suggestion would be to FOIL this stuff out first over here, this stuff, and then distribute the x at the end. Okay? Now, we're not going to do that because it's kind of a waste of time, but let me show you something real quick. This is going to lead us into the next part. Freely! Shush. All right, see this right here? See how 4 happened twice? That's special, and it's going to have a special term, okay? So here we go. We're going to talk about multiplicity. Now, a long time ago, I don't know how long, maybe like 15, 20 years, there was a movie called Multiplicity. Yeah. Yeah, what was his name? Michael Keaton, I think. He was, yeah, he was Batman guy, right? He was Batman? Keaton? No, he's not. I don't think so. No. Anyways, he cloned himself in this movie. And there was a whole bunch of himself. And it was called Multiplicity. Yeah. So, no, lots of movies aren't. So, all right, so multiple 0 is a repeated 0. Okay?
Was it a good movie?
No, I don't know. I don't even think I saw it. All right, a repeated 0. I just know that that's what it was called. Now, for up there, do you see how 4 happened twice? 4 happened twice, right? It has a multiplicity of 2. Okay, multiplicity is the number of times a 0 repeats. Now, people will say that something has a multiplicity of 1. That's not true. You cannot have a multiplicity of 1. Okay? Multiplicities start at 2, 3, 4, so on and so on. Okay? If a factor or a 0 happens more than once, like that 0, 4 happened twice, then it says they say it has a multiplicity of 2. All right. So knowing that, we are going to find the zeros of these 3, and we're going to state what their multiplicity is. Okay? In order to find the zeros, you need to have it in factored form. So good news, the first 2 are already factored for you. The last one we'll have to factor, but we're going to go ahead and state the zeros. So let's look at this first one. So if you look at these, we have a factor here, and we have 2 there. And so our zeros are 2 and negative 3. And negative 3 happens twice because this is x plus 3 times x plus 3. Do you see that? It's x plus 3 squared. So that 0 happens 2 times, so we say it has a multiplicity of 2. So the 0, 2 only happens once. There's 1 factor for it. But negative 3 has 2 factors of it, so it has a multiplicity of 2. Like me and my sister, twins. I have a multiplicity of 2. All right, over here, let's take a look at these. This right here, x to the 4th, what would make that 0? 0. Okay, don't forget that one. And then how many times does that happen? How many zeros are there in that 0? 1, 2, 3, 4. It's x to the 4th. So 0 has a multiplicity of 4. All right, now let's look at the next factor. I have x plus 1. So x equals negative 1. That one happened 3 times, but wait a minute. Before you write down multiplicity of 3, look right next to it. How many times does that x plus 1 occur? 5 times. Good. It has a multiplicity of 5. I actually did that one wrong earlier. like yesterday. And then people are like, no, it's 5, because I was getting there. I would have done it, but yeah. I was going to say 3, and then another 2, so that makes 5 of them. That's right. Okay, so now let's do the last one. The last one is not factored for you. You cannot tell what the zeros are unless it's in factored form. So we need to factor out the GCF, which is what? Good, x squared. Perfect. So x squared plus 6x plus 8. And now we're going to factor that. Maybe you want the star method. That's fine. You still like it. Put the 8 up top, 6 on the bottom. A 1 goes there and there. 2 numbers that multiply to give us 8 add up to 6. 4 and 2. Perfect. X plus 4, x plus 2. All right, once it's in factored form, and that's a lot of work to do just to get it, just to find your zeros, but you're pretty good at factoring by now. So our zeros will be that we have 1, 2, 3 different zeros. We have x equals 0, but that has a what? Multiplicity of 2. See, it happens twice. X times x. And then x equals negative 4. No multiplicities, and x equals negative 2. Now, what degree polynomial is this? It's degree 4. Quintic. Quintic, yeah. It's degree 4. A degree 4 polynomial will tell you there are 4 zeros. But you're like, wait, I only see 3. But how many times did 0 happen? Twice. So 2, 3, 4. There's 4 zeros. Okay? All right, last page. We're almost there. All right, you're going to need your calculators for this page. So if you have your calculator, get that out.
You need a graphing calculator.
You do. It's a Quintic, yeah. Okay, so for graphs, this is what we're going to do. No? All right, that first problem that we did on the first page, it had zeros of 0, 5, and negative 3. If I were to graph that polynomial on my calculator, which I'm going to in a minute or two, I just want to talk about this first. What would happen is your x-intercepts would be negative 3, 0, and 5. Okay? So the zeros are negative 3, 0, and 5. And the zeros of a polynomial are also its x-intercepts. We learned that last chapter on a smaller scale when we did quadratics, and we graphed it, and we found the zeros were the x-intercepts. Okay, that polynomial, this is what a cubic polynomial will look like. The one that's on the front, it looks just like this. Watch, it goes like this. Ew. Dang it. Try that again. It goes like this. We're going to graph these on our calculator in a minute.
Didn't you do that the other day?
Do what?
Because you did a bunch of graphs.
Oh, yeah. Polynomials show up a lot. I don't even like that one either. All right. Let me try this again.
I remember in 3rd grade.
That's better.
It was my homeroom teacher, and their room was 305.
Oh, okay.
No.
Oh, because okay. I was like, thanks for sharing. No, I get you. I hear you. Yeah, 305. Isn't it funny how you remember stuff like that? Like, I remember my license plate when I was 16. I don't know why. That's dumb. Okay. From when I was 16. Yeah. 2YQL546. Okay, here we go. This right here has some very special points on it. We found 3 special points. 1, 2, 3. And those were the zeros, which are the x-intercepts. Now, there's 2 other special points. There's this special point at the top of that mountain. And then what other thing do you think special? At the bottom of that mountain, or valley, I guess. Okay? Now, those are called something. This graph right here goes forever down, and it goes forever up. So there is no maximum or minimum y values. But this one right here, this point, this is called a relative maximum. What that means is it's the biggest, it's the highest peak in that neighborhood. It's kind of like if you live in a neighborhood and there's like a nice hill and there's someone living on top of that hill, he's the, king of the mountain. But then there's a mountain that's farther away. He's not the king of that hill, okay? So that's just a relative maximum. It's the maximum in this neighborhood of points. This right here, what do you think that's called? Yep, exactly. Relative minimum. And our calculators are going to help us find those points. We don't have to do them by hand, okay? All right, so let's do it. We're just going to do one of these, and then we'll do the summary, and that'll be it, okay? So let's do number 4, letter A. So we're going to go to our calculators, and we're going to graph this. All right, so I hope you brought your calculator, because I want to make sure your calculators are working right and you're plugging these in correctly. So go to y equals. Clear anything out, but you can leave y2 as 0. Okay, we're going to need that. So number 4 says to graph the function and find its zeros and relative maximum and minimums. So let's graph this. Now, do you know how to do a cubed on your calculator? We're going to go 2x to the 3rd power. It's this caret right here, this underneath clear. Caret. That's what it's called, a caret. 2x to the 3rd. Now I have kind of a newer calculator where it actually brings it up there with me. I don't want to keep going up there. I want to arrow back down, okay? So 2x to the 3rd plus 10x squared plus 12x. All right, now hit zoom 6 so we have a standard window. And you get a nice little cubic function, nice little polynomial. Polynomials are beautiful. They're studied a lot because they're smooth. There's no weird like corners or cusps or discontinuities. There's no breaks in the graph. They're just nice, smooth curves. Like a line is smooth, a parabola is nice and smooth, a cubic function is smooth. Okay, you get the idea. Smooth curves. All right, so let's go ahead and we're going to find the zeros. Now you can factor this and find the zeros. It is factorable. But we also know how to find the zeros on our calculator. The zeros would be the intersection with the line y equals 0. And you guys know how to do that already. You just did that on your test. All right, so second trace. We're going to go to number 5 to find the intersect. Make sure, though, that you have y2 equals 0. Because you can't find the intersect of one thing. It has to be two things. All right, so hit enter, and hit enter 3 times. And I first get x equals 0 is a 0. Did you get that? And that's true. Look at it. Like if you just look at your polynomial, can you see if you plug in 0, you'll get 0? Yeah, because there's an x for every term. All right, now calculate the intersect again. And let's arrow over to the next one. And that one is -2. These are really nice. So -2 is my other 0. And then finally find the last one. There's 3 of them here. There's 3 x-intercepts. Hit enter 3 times, and we get -3. Okay, when you go to sketch this, you can go to 0, -2, -3. Now, I'm not too particular about how high or how low you go, so you can just kind of sketch it. It goes up a little bit, it drops down farther, and it goes like that. So just sketch the graph. And now what we're going to do is we need to find those maximum and minimum points. So this is new. So if you've been tuning me out so far, you might want to pay attention now, okay? Yes, Fraley. All right, maximum. The relative maximum is this point right here, okay? Now, do you know which side is the left side of that maximum and which side's the right side of that maximum? Let me show you. If I drew like an imaginary line through it, this is the left and that's the right. Do you agree? Left side, right side. Because your calculator is going to ask you for that. So here we go. We're going to go to second trace again. We're going to calculate, and look at these words here. Look at number 4. What does 4 say? Maximum. We're going to calculate the maximum. Okay? And it's asking me to be on the left side of the maximum. That's that blinking thing there. Am I on the left side? Are you on the left side? If you are, you hit enter. And what your calculator does is it puts in this little triangle. So it's saying, okay, I want to go to the left of that. Do you see that triangle right there? Ooh, some of you with your new calculators, you get a line, don't you? Yeah. Oh, I want that calculator. I'm going to buy it for myself, wrap it up, and say it's from Santa. Okay, now, that's really sad, isn't it? A little bit. That's okay. It'd be a great Christmas morning for me, though. All right, now go to the other side, because it's asking you to go on the right bound. It needs a right bound on that side, so hit enter. And guess what it did? It put a triangle going this way. or a line. So it's going to find the maximum point in that neighborhood. You hit enter one more time, and there's the maximum. Okay? You cannot just trace it up there. Some people think they can just trace it. It's not going to give you the exact point. If I use the calculator and I do maximum, it gives me the exact point. So I want you to write the maximum as a point. The maximum is negative 2.55, comma 1.26. All right, we're going to do it again. But we're going to find the minimum this time. Oopsie. So here's the minimum. I'm going to do the exact same thing. Do you want to try it?
No.
Without me? No? Okay, go to second, trace again. This time we're going to go to number 3, the minimum. Okay, it's going to ask you to go to the left side of the minimum. So I'm going to go over closer to that minimum. You see that where it's blinking? It's definitely on the left side of the minimum. I hit enter. It put that triangle in for me. Now I want to go over to the right side of the minimum. I hit enter. And so it's going to find the minimum value in that neighborhood. And I hit enter one more time. And there it is. It even shows you where it's at. It goes right to it. And the minimum would be x is negative 0.78 and y is negative 4.23. Sometimes you have to change your window. You don't like it?
No, I'm like, I don't know.
You're not sure?
Yeah.
I know, it's brand new. It's hard, really hard. Okay. Are you ready for the summary? Here's the summary. If we have a function that looks like this, a quadratic equation, x squared plus 3x minus 4, then x plus 4 and x minus 1, these are called factors, okay, because this polynomial factors into those two factors. We know those are called factors. Now, from those factors, we get from this one negative 4 and from that one positive 1. We get what? We get something that are called zeros. Those zeros, if you plug them into your equation, they're also solutions. They're the solutions of that equation. And when we graph them on a graph, they are called what? The x-intercepts. Perfect. Those are all those things, okay? And that's it.